Hello everyone. So in this project we are going to look into machine learning for predictive analytics. That is how we can use machine learning for predicting any future values or future trends, future profits or loss. Uh, like if our business will be profitable in upcoming business months, or if users will buy a certain product in the upcoming months, or like if the coronavirus will be affecting as much as the previous month, like we can predict future incidents, future incidents or future trends using predictive analytics. So in this project we are going to look into reducing monthly churn by identifying high risk customers well in advance. Now, in about the project relates to applying predictive analytics on customer churn. A major telecom company's postpaid business of voice-only plans is struggling to maintain its stronghold in local market because one high churn rate among customers, leading to revenue decline of approximately 500k US dollars every month, and decline in overall customer base, leading to a decline in a total market share. So we will find out about the best classification model to predict the churners for the upcoming month in advance, and identify the key features that are affecting the churn. So at first we are importing all the needed packages and libraries for calculations and as well as visualizations and data manipulation. Now we are mounting our Google Drive into the Google Colab so that we can import our dataset directly from the Google Drive. Now we are creating customer underscore df and using read csv function to read the data from the csv file, and here is using .head function to see what the first 5 rows of the data set looks like. Now the basic things that we have to do, that is, at first we will explore the data, and as we can see that the customer df.shape returns that we have 51,047 rows and 58 columns or features, and here is the basic info about the data set, that is normal objects and data types, etc. Now customer df.columns returns all the name of all the columns or features in the data set, and is null.sum is returning number of null values in each and every column of the data set. Now we have to find out the missing values, outliers, unexpected values, and clean the data set from those. So first we are seeing how many customers had monthly zero revenue, and as we can see that we are getting that 6 people have monthly revenue of amount 0. Using customer df dot monthly revenue column is equal to 0. So we are comparing this, and we are returning the length of how many are true, how many are returning true respect to this. Now we are seeing if the columns with missing values or missing or null values, the number of null values, if they are greater than 5% or not. And as we can see here that the most percentage of null values is 1.78, as we can see here. So now what we can do, that if the number of null values is less than 5%, so if we drop those rows also, or those records also, that won't affect our prediction or dataset that much. So we are once again checking to be sure that if there are any column with missing values greater than 5%, but there are not, so we are going to simply drop those columns. So we are using drop and to drop, and now if we check, we get that there are no more null values present here. Now we are checking for any outliers and removing them, because those outliers are outside of the general trend of our dataset and may affect our predictions. So we are checking the outliers for unique subs and director assisted calls column, and here we can see that there are some outliers present. And now we are getting the top 1% of the values from both the columns that are the outliers. So as we can see that these are the values. Now we are checking the minimum and maximum threshold for the unique subs column, and as we can see that these are the minimum and maximum thresholds, and if we are checking that if there are any values present less than or greater than the minimum and maximum threshold, and we are refining the dataset by saying that if there is any if they that the dataset will only contain the values or records that have less than the values that are between the maximum threshold and greater than or equals to the minimum threshold of the unique subs dataset. And now again we are checking that the minimum and maximum threshold of the other column, that is director assisted calls, and here we also doing the same, that defining that this is the limit between which the records will be present in the data set. And now if we check the box plot, the outliers are there are not that many outliers, and the data set follows a general trend here. Now we are performing some exploratory data analysis to analyze the customer chart. So we are seeing here some trends like the does customers with high average minutes also have high revenue, and as we can observe from the scatter plot here that the positive correlation between there's a positive correlation between average minutes and monthly revenue. Therefore we can say that the customers with high average minutes and has high monthly revenue, though say there may be some exceptional cases there. Now we have to observe that if the high number of active subscribers lead to low monthly revenue, and as we can see from this categorical plot that this is also true, that in that high number of active subscribers lead to low monthly revenue. Now does credit rating have an impact on churn rate? And as we can see from this cross tab that from this cross tab as well as this count plot, that credit rating does have an impact on churn rate. From the cross tab we can see that the higher the credit rating, the higher the churn is. The only exception are the highest and the lowest credit ratings. Now we are doing some additional exploratory analysis, that is we are plotting the correlation heat map here to observe the correlation between the different features, and we are plotting a count plot to observe the yes to no ratios. And as we can see that there's a significant difference between the number of no's and yes records, so we can say that the data is biased. So we in case of prediction we may have to perform under or over sampling to get a more accurate result. And now we are seeing the count plot with respect to churn and occupation, and now we are creating some additional features that will help us in predicting the churns, that are percentage of active subscribers, percentage of recurrent recharge, and percentage of average minutes. So these are the corresponding formulas to find those three, and we are returning the customer underscore df. Now after this customer underscore df we are creating these features into the original dataset using the create features function. And now as we can see that we have those three features here present here in the original data set. Now we are going to build the classification model, and as we know that in case of ML operations we mainly operate with the numerical values and not categorical values, and as the churn column is present with values like yes and no, so we have to convert them into numerical values like 0 and 1. So we are doing that here, like we are assigning 1 to yes values and 0 to no values, and we are applying the changes to the original dataset. And as we can see here that the values have been changed. Now we are checking if there are any more null values, and again the values are less than 5%, so we are dropping those, and we are replacing here the infinite values so that we don't have any obstruction while operating. Now we are doing the oversampling because the data is biased in case of no values. So we are seeing that we can see the difference between the difference between the record number of records with 0 and 1 values. There is a huge gap, so we are doing random oversampling and taking the same number of records for both yes and no. Now we are importing the train test split from sklearn.model selection, and we are selecting all the features from the dataset for the x is for x except the churn column, because churn is what we will predict, and we are assigning churn to y, and we are doing pd.getDummies on x because we want to convert all categorical values present to the numerical values for the sake of the ml operations. Now we are importing the standard scaler from sklearn.preprocessing to scale all the continuous variables present in the dataset, and finally we are splitting the dataset into train test split, and the test size here is 30%. Now we are applying logistic regression on at first to check how much accuracy the model provides, and as we can see that the model provides only about 60% accuracy. That is not that good in case of business analytics. Now we are also seeing that the confusion matrix, which is a technique to summarize performance of the classification algorithm, which can be misleading if and the accuracy can be misleading in these cases, because if we have unequal number of observations in each class, and we have more than 2 classes in our data set. So the confusion matrix return these values, and we are assigning the true positives and true positive, false negative, and true negatives according to the matrix. And now we are going to see precision, recall, and some more parameters to check our model accuracy. So precision is how certain of we are of our true positive values, and recall is how certain we are that we are not missing any positive values. So in case of precision, we can see that it is also returning 59%, and in case of recall it is also returning 59.3%, approximately the same, and the F1 score is 59.18. Now to check if our model will perform how our model will perform on a test dataset, we are using AUC ROC curve, which measures classification problems at various threshold settings. ROC is a probability curve, and AUC represents the degree of measure of separability. So here we are seeing that AUC score is 59.45, and the area under the curve of ROC curve is 0.59. So in case of ROC curve, we can say that the near the value is to 1, the better the model will perform in case of the test dataset. So we can say that this will perform but not that good. And we are also seeing the average precision score and the precision recall curve. Now we are going to check if the random forest classifier model is a better option or not, and we are importing random forest classifier from sklearn.ensemble, and we are specifying CLF is equal to random forest classifier. Number of trees in the forest will be is equal to 100, which is by default 100, and we are fitting the dataset, and we are saying ypred is equal to CLF dot predict function x on x test, and we can see the array ypred array here, and we can see that the accuracy is 89%. That is very much good. That's a huge improvement than the logistic regression data set. And the confusion matrix, also the corner values are very impressive. So we can say that this is definitely a much more better model. Also we are doing the same here, true positive, false negative, and true negative values from the confusion matrix we are assigning, and we can see that the precision is 92.48%, the recall is 86.47%, and the F1 score is approximately 89.37%. The AUC score is 89%, and as we can see, the area under the curve is also 0.89. So we can say that this is a much better model than the logistic regression, and also the average precision and precision recall curve tells us the same. Also we are checking the accuracy for the XGBoost and decision tree classifier, but in case of XGBoost we can see that it is approximately 64%, and in case of decision tree classifier it is 80%. So we can say that the best model here is the random forest classifier. Then we can use decision tree, then we can use XGBoost, and the logistic regression performs the worst in this case. So as we can see from the aforementioned result, random forest classifier is the best model for predicting churners and non-churners for the upcoming months in advance. And here we are going to see the top 20 features that are affecting the churn the most, and here we can see from the lowest to the highest the features that are in the top 20 of in case of affecting the churn. So now that we have selected the random forest classifier as the best model, now we can easily apply the model on our test data set and find out our churners for the next month in advance, and take countermeasures to retain those customers or improve our business policies later on. Thanks to NAI for providing us with this project, so that we get an insight into the real life business problems and analytics and how it all works. Thank you.